Okay, it seems that we're live. So in this stream, I'm putting together a local library for the components that we're going to be using in the drone power supply project. I've described this project in the previous video where we put together the schematic, and I've also chosen many of the components, but I've realized that actually there is a better way to administer the whole component library in KiCad, even though I don't think that KiCad is actually designed for this kind of workflow, but it is a very good workflow nonetheless. So what I do is I put all of the components, so you can see with this resistor here, this is a custom created component, and you should make component creation an integral part of your design workflow. So component creation is basically just like laying out the schematic. It's just like placing a capacitor in this schematic. The same workflow is actually creating this capacitor as a custom component. You should never shy away from it. There are some people I've heard that are, electronics engineers, and they say, well, I'm not going to be creating, or like I'm blocked because I don't have all of the components. Well, sorry, you have to create your components yourself. That's kind of like basic. That's like typing in a text editor if you're a programmer. So I've started putting together the library, and it is right here. So I call each component, each resistor, for example, with a distinct value becomes a component, and each component is a distinct symbol. So we can assign a footprint directly to this component, and when we reuse this component on another schematic. So part of the reason of putting it together like this is because it allows reuse, and it also allows you to double check your library and make sure that all components are correct, and make sure that all of them are also bound to actual products which are purchasable. And so when you export this into a BOM, you get this manufacturer number directly in the BOM. So once you've created a PCB with this component and you know it's correct, you can actually store it away in a library that you can then reuse later in another project. And you wouldn't have to go through the process of reassigning the footprints, which I find personally is quite an error-prone process to create a schematic in KiCad and then assign footprints manually for every single board that you make. I think that's duplication of effort, and I think it's a very error-prone way of going about doing things in KiCad. So this is a much better approach. So let's see what we can add next here. So we have the 18K resistor. We're gonna go back to the schematic, and I'm gonna see where we are at here. So 18K resistor is right there. Next we see we have 100K, 523K. All these resistors I've already added to the library. 25.5K. Do we have that? So I'm creating the library before actually swapping out the components for the new components that I'm creating in this library. So right now I'm just going I'm going through the components, and I'm pasting in the manufacturer number because I already have that in an Excel document, but I don't want to have it in an Excel document. I want to have it in KiCad. So I can go back here and I can duplicate this resistor, and I double click on it. And then I set the manufacturer number. Let's see, I'm gonna just bring up the, right, 18K. Do I have that in my table? No, I don't have that in my table because this is a 6 volt supply there. Let's see, let's find it. Let's find a resistor that is 18K, and it's 1%, and it's 0.603. For some reason I didn't have that resistor in the BOM. So let's pick a resistor here, and then we'll go. Do we have 18? Maybe, let's see, just paste it there. Wait, let's see, what am I doing here? Did I just create two 18K resistors? Right. I think I meant to pick some other resistor. I meant actually to pick the 25.5K resistor. And I picked the 18K resistor, which I already added previously. So I'm gonna go back to the Mauser page, and I'm gonna find a 25K5 1% 0603. Great. So I take the manufacturer number. I always take the manufacturer number, by the way, because if I take the Mauser article number, then I can only use the Mauser. If I take the manufacturer number, I always have a direct reference to the actual component. So then I can go back to the library, and I can actually update this field to the new value. And then I update this. So one of the reasons that I don't think that KiCad has been originally designed for this workflow is because it doesn't allow you to set arbitrary name for the resistor using the value. So the value here ends up being the component name, which I find really weird. So I don't want this value to kind of appear in on the schematic, but at the same time I want to name my components in one way and then set the value in a more human readable way. So this is good to prefix the components with resistor, for example, RES for the resistor, and that basically means that they will be ordered in the library. But then for the actual value that goes in the schematic, I want to just have 18K 1%. I don't want to have this ID as a value in the schematic. So so I decided that I'm going to do it this way. And this also allows me to see which components that I've created myself, the components that I've processed, and which I haven't processed. And I think this is a rather neat way of putting it. So like 25.5K, and we can even do we can even shorten it a little bit and put the K in the middle so we can get a shorter string. And that's it. And then I go to the next component. Did I forget anything, by the way? Did I forget anything on this component? I don't think so. I'm gonna find out later. When I do the BOM and then I go through all of the manufacturer numbers, I may actually notice that I made some mistake and just copy-pasted a wrong manufacturer number. But that's a separate step, and that step is something that you always have to do anyway in the end. But luckily, if you work like this, you only have to do that step once. So once you have validated your components and you know that they're correct and you know that the footprints are correct, then you never have to do that again, which is very nice. So here in the fields dialog, I can also select the footprint for the resistor, and then I don't have to assign this footprint later. So let's see what else we have left here. So we have 25.5, and I think we have 143K resistor left, and that's all for the resistors. $143K. And 143K resistor has a manufacturer number that is right here. That's it. So I'm not going to go through all of the components, but you kind of get the idea. And for example, the battery component, there is usually in KiCad you have like generic symbols. So generic symbols go that far, but they don't go all the way. So it's kind of like in Altium Designer you have your vault, and you can download components from the vault. But I find it a better approach to download the components that are already done, so you don't have to redo them, but then to have local copy of the components where you actually assign the more details to the component that are kind of unique to you. So, for example, the components that I'm using here, they are not very useful for somebody else who is designing a schematic, because that person would have their own suppliers, that person would have different manufacturer numbers, so they have to go through that process themselves, and they have to make their own library where they put all the fields in, where they have well-defined components with pre-assigned footprints, which they can then use in different designs that they design. And I think that this is something that every designer should get really, really, really comfortable with. As a designer of a schematic, when you draw the schematic, you really have to get comfortable with designing your own components and putting them together on your final schematic. So in this version of KiCad, what I can do, this is by the way version 5 of KiCad. I'm not sure if this if the older version has all the features that I'm using here, but in this version I can definitely just there are many new features that make this kind of work easier. So I can go here and I can change the footprint, or the actual component, to, let's see, so this was 523K. So I can change it to 523K. Well, that was weird. Or no, it wasn't. But I have to go back to the library and just double check. 523K. So what the hell is going on? Let's see. What is this? Okay, so for some reason it doesn't load the visibility. So this is something probably that KiCad needs to fix. And it actually didn't load the manufacturer number either. I find that very weird. This seems a bit wrong. Right. So what I had to do is reload schema, because apparently for some reason schema wouldn't automatically reload the libraries that I've updated. Maybe there is some button for that. Let's see. Is there a button that updates all the libraries? I have no idea. But maybe you know, in previous versions of KiCad, usually when I updated the library, I had to like add just click to add a new component, and when I would do that, it would actually reload the libraries, and then I could get the latest version of the symbol. So let me go here. We just replace this resistor with a, oh, let's see. I didn't actually check what the value was. 84.5. Okay. And replace this with an 84.5 custom resistor, which is right here, and update field values. And that didn't work either. That's interesting. So what's going on here? Maybe I actually did have the latest version. So this is a rather new workflow that I'm experimenting with in KiCad. which I haven't been using before. So this is kind of like I've been looking for ways in KiCad to improve the workflow such that I wouldn't have to go through the process of assigning any kind of properties on any component when I reuse the components. I want to just define components, and then I don't want to touch them again. I want them to be validated, and I want them to be correct, and I want to know that they're correct, and I don't want to manually set any properties on any component that I add into the schematic. So let's see. Maybe there is a default list of properties somewhere. Okay, so that's interesting. I think there is a little bit of a problem here with how schema currently works with the components, and that is that schema has actually fields assigned to the elements on the schematic, which it doesn't automatically reload. For example, the visibility here, when I actually click the update fields, it did not update the visibility of the field. So this seems to be saved as part of the schematic. So if I added this component right away as the correct component, that would probably work very fine. But if I replace a component, it doesn't really seem to be optimally designed for that kind of thing. So I have manufacturer number here. And I changed the component, and I set that to, what was that, a 13K resistor? Yes. Okay, does this work? Okay, so there is clearly a bug here. So when I click update fields, I don't get the manufacturer number here, so I cannot update it. If I click OK, and then I reload this dialog, and I go here again, I can see the manufacturer number there. So that is clearly an issue with KiCad. So I'm going to go ahead and clean up this schematic, and then I'm going to go through the capacitors and through the inductors, and I will add custom components for all of them. Now, one thing I want to mention is that previously, on the previous version of this schematic, the battery was just like, I just use a pin header, right? So there's a problem with that. If I then go and I go through like the standard way of just annotating the schematic, generating, let's see, annotating the schematic and assigning footprints, and when I do that, it could actually mean that if I have used a component that has pins reversed, and I then assign a footprint that places the positive pole of the battery onto like a negative, on the negative side of the connector, then obviously things wouldn't work, and I would have to redesign the PCB. So when I create those custom components, that is also an opportunity to kind of go through every component and double check that the footprint is correct, and double check that any other parameters are correct, and the pinouts, and also just adding extra information on the actual component that you then put in the schematic. So it's like you have full control of the schematic when you make the creation of new footprints part of your integral workflow of designing the schematic. So that's it for now, and I really don't want to bore anybody with like going through all the rest of the components, because it takes time, and it's a rather boring process, but I only have to do it once. So I'm gonna stop the stream, and I hope you learned something. And in the next version of this series, I'm gonna be placing and routing the PCB. See you next time.